Hi, I'm Chris from FlipMath, and you're here for today's lesson, which is on coordinate geometry, and I'm calling this one Bisecting the Perpendicular. It's a part of the C1 AS modules, and also part of my mathematical methods course. The contents should be the same in both cases. Objectives for what we're going to do in this little recap video. We're going to calculate the equation of a line parallel to another line. We're going to calculate the equation of a line perpendicular to another line, and then calculate the equation of a perpendicular bisector of a line segment, and I'll explain what that is as we go through. Okay, so a little introduction. We're going to start by plotting a few points and then calculating the gradients of them, and then we'll make a couple of observations over what we see, both in terms of the value of the gradient and also what we see with our eyes. So we're going to investigate the relationship between two pairs of points. And what you should know, well, you should be able to calculate the gradient of a line between 2 points. And if you can't, you can go back to the previous video and see C1.3.3, which was the equation of the line, and how to calculate the gradient is in there. As a general reminder, the equation for calculating the gradient of the line is m equals y2 minus y1 over x2 minus x1. Okay, so we're going to calculate the gradients of lines between the following sets of points. First two that we're going to do is 1, 1 and 3, 5. Okay, so we're going to set 1, 1 as the x1, y1 and 3, 5 as the x2, y2. And if we do that and plug those into our formula, our y2 minus y1 becomes a 5 minus your 1, which is 4. And then 3 minus 1 is our x2 minus x1, and that gives us 2. And 4 divided by 2 gives us plus 2. First one done. Second set of points is 3, 1 and minus 2 minus 9. Same thing, we're going to set 3, 1 as our x1, y1, and our minus 2 minus 9 is x2, y2. And we're going to plug those points in, and just be careful with your signs. Our y2 is minus 9, then we have minus our y1, which is 1, divided by the minus 2 minus 3. That gives us minus 10 divided by minus 5. If we look at our signs, a minus minus gives us a plus, and a 10 divided by 5 gives us 2. As you see, both lines have a gradient of plus 2. And we're going to plot them to see what exactly that looks like. So the same slope, and you may realize what's going to happen already before we do it. So if I plot the points, I've got a nice little grid here. Each square relates to 1. So the positive is in that direction and the negative is in that one. And similarly, positive in that direction and negative in that one, if you know your Cartesian plane at all. So we're going to plot 1, 1, and that's 1 across, 1 positive, up 1 positive, and that point will be there. And if I plot 3, 5, again 3 across and 5 up, that point's going to be there. We're going to draw a line, join the 2 points, something like that. And then we'll do the same for the other points. We're going to plot 3, 1, which is there, minus 2 minus 9, which is there. And I'm going to draw the line joining those 2 points. And as you'll probably see, what word can be best used to explain the relationship between the two lines? You hopefully will come up with the idea that they are parallel. A parallel means lines that will never meet at all. So they'll go on forever and ever and ever, a bit like train tracks. They should never meet. And it should be pointed out then, if the gradient of the first line is plus 2 and the gradient of the second line is plus 2, then parallel lines have the same gradient, and we can make that observation. And that's the thing we should remember and know. So we're going to look at a problem that takes that information, and we're going to use it to problem solve a little. So we're going to calculate the equation of a line parallel to another one, and we're going to use our y minus y1 equals m upon x minus x1 equation that we've seen in our last lesson. So I'll take you through a bit of this at the start. The question is, work out the equation of a line that passes through the point 4 minus 2 and that is parallel to the line y equals 3x plus 7. And if I take you through the equation that I had just before, the y minus y1 equation, you can see that we've already got all the bits of information that we need already. So I've highlighted in red here the bits that we need. We need 3 values. So we need a y coordinate of a point that lies in the line, which we can see here. So the equation of a line that passes through the point 4 minus 2. So the y coordinate is this one here. So that's our y1. Our gradient, m, next one across. Well, we know the parallel lines have the same gradient, which we'll come back to in a second. It's there. And the x coordinate of a point that lies in the line is, as I just pointed out to before, the x coordinate that's up there. Okay. So 4 minus 2 is our x1, y1. And we need the gradient of our line m. And as I said, the parallel lines have the same gradient based on what the experiment we did last time. So the gradient of the line y equals 3x plus 7. The gradient of that line is 3. So the gradient of our line that's parallel to it is also 3. So taking this forward, I'm going to put these values into the equation on the next page. But I'm going to take my m as 3, my x1 is 4, and my y1 is minus 2. So with that in mind, I'm going to plop each of those values into our equation. So we should end up with y minus 2 equals 3 upon x minus 4. And if I multiply the brackets and simplify my signs, I'll have y plus 2 because the minus 2 becomes a plus 2. Of 3 times x, which is 3x, and 3 times minus 4, which is minus 12. The only thing that's left to do is take the plus 2, move it to the other side, so it becomes minus 2, and I'll end up with y equals 3x minus 14, and that is the answer to our question. The asked us to work out the equation of the line that passes through 4 minus 2, and that is parallel to y equals 3x plus 7. All good. And that is that objective covered. So, with that in mind, let's add another coordinate to our little diagram beforehand, and we'll calculate the gradient for it as well, and we'll see if we can come up with anything interesting. So we're going to invest the relationship between another set of points, and again, you should be able to calculate the gradient as before, using our y2 minus y1 equals over x2 minus x1. So we're going to do 6 minus 2 and 0, 1. I'm going to set the 6 minus 2 as x1, y1, and the 0, 1 is x2, y2. And once we calculate our gradient, we'll plop in our points of 1 minus minus 2, which gives us 3, because the minus minus gives us a plus. And then you have nothing take away 6. Nothing take away 6 is minus 6. So 3 divided by minus 6 is minus a half. So the gradient of our new line is minus a half. And we're going to plot this line with the existing lines to see what it looks like. And if I do that, there's our existing lines. I'm going to plot 6 minus 2. I'm going to plot 0, 1, and I'm going to draw a line going through the two. Now, it mightn't look exactly like that, but if we can pick a word used to describe the relationship between those, the new line and the parallel lines, we should come up with the word perpendicular. And perpendicular means at right angles too, so at 90 degrees, a bit like the corner of the table now. Because of the way I've drawn this with the nice thick lines, it probably doesn't look exactly at 90 degrees, but if you draw it on Desmos or something like that, that gives you the same bits, the same information, but in a slightly more accurate form, you will see that it is 90 degrees. Let's look at the gradients that we worked out though, because the parallel lines had a gradient of plus 2, so the two like yellowish orange lines have a gradient of plus 2, and the perpendicular line is one of minus a half. And the key part is this: if we multiply these two gradients together, the plus 2 and the minus a half, we get minus 1, because 2 times minus a half, or 2 lots of minus a half, gives us minus 1. And the bit to know is the perpendicular lines gradients multiply to give minus 1. I'll show you how this is useful, or how we can use this in the next page. So we're going to calculate the gradient of a line perpendicular to another one. So I'm going to give you two examples here, where I'm going to give you the gradient, and that you're going to calculate the gradient for a line that would be perpendicular to it. So if I give you I've got a line with gradient 2, we're going to call our perpendicular gradient m, so that if I multiply the existing gradient times my perpendicular gradient, I'll get minus 1. So 2 times, when I multiply these two gradients together, I'll get minus 1. And if I arrange this, if I move the multiply by 2 over the other side, it will come divided by 2, and that will give me that the perpendicular gradient is minus a half, because multiply by 2 will become divided by 2. If we give you another one, minus a third. So we're going to do the same thing. A minus third times our perpendicular gradient m will multiply to give us minus 1. And you can think of this a few ways, but I would tend to group the minus third m as minus 1 times m gives us m. So it'll be minus m over 3. And I'm going to move the minus 3 over the other side. What's the minus 3 doing on this side? It's dividing. When I move it over to the other side, it'll become multiplied. So I'll have minus 1 times minus 3, which will give me plus 3. And our perpendicular gradient will be plus 3. So we're going to take this information and we're going to use it to solve an exam style question. So very much like last time, we're going to calculate the equation of a line, but this time it's going to be perpendicular to another rather than parallel to it. And we're going to use our y minus y1 equation like we've used beforehand. And let's see what we need to calculate. So the question is this. Work out the equation of a line that passes through the point minus 5, 2 and that is perpendicular to the line y equals minus 2, minus 9. Okay, so we'll still need to find our three values to substitute in. Our x1, our y1, and our m. And we can see that we have a point that we know is already on the line, so we have been given that already. So that's just like before. We've been given that minus 5, 2 is our x1, y1, because it said that it passes through that point, so we know that's going to lie on the line. We need to find the gradient of our line m. Now, perpendicular gradients have gradients that multiply together to give minus 1, like we just discovered. And with that in mind, we can see that the gradient of our original line, or the coefficient of x, is minus 2, like we can see. So with that in mind, we can do our minus 2 times our perpendicular gradient that we're trying to find is equal to minus 1. If I divide across by the minus 2, I'll get minus 1 divided by minus 2, and the minus simplifies down to give us a plus. And we get our perpendicular gradient to be a half. So we're going to take those three values, and we're going to substitute them in. So our y1, as we've seen beforehand, is here, is 2. So it'll be y minus 2. And then we're going to have our m, which we worked out before, to be plus a half. And then our x1 is our minus 5 up here as well. So we'll pop that in there as well. We'll multiply it our brackets, or we'll simplify our brackets, should I say first, but the minus 5 become plus 5, and then multiply out. So we get y minus 2 equals a half times x is a half x, and then a half times 5 is 5 over 2, or 5 halves if you want. Last thing we're going to do is move the minus 2 over to the far side, so it becomes a plus 2. That will give us y equals a half x plus 9 over 2. And that's our answer to the question to work out the equation of the line that passes through minus 5, 2, and that is perpendicular to the line y equals minus 2, minus 9. And I've given you the little shortcut for perpendicular to, which looks like that. It's like a right angle and like an upside down T. That's supposed to be an R, rather badly drawn at the side. And that is to calculate the equation of one line perpendicular to another. Okay, so we're going to look now at perpendicular bisectors. Everything we've learned so far is kind of encapsulated in this one thing where we ask you to work out the equation of a perpendicular bisector, and it's the longest version of the type of question, but it's also one which has got elements which you have done all before. So we're going to look to see what a perpendicular bisector is first, and it's a line that goes through another exactly halfway along. So if I draw a line like that, it'll be one that cuts it at right angles, like there, exactly halfway along, like the red one's doing there, or should be nearly exactly half. We already know how to calculate the perpendicular part, but we need to be able to calculate the midpoint, or the bit that's halfway along. So it's time for another formula, really. Although many don't actually use this one all the time, so they don't necessarily need to use this one, because in order to do it, the midpoint of two lines is x1 plus x2 over 2 and y1 plus y over 2. Basically, you're taking an average of the two x coordinates divided by, so add the two of them together and divide by 2. And taking an average of the y coordinates, add the two together and divide by 2. So for example, if I can calculate the midpoint of minus 1, 4, and 3, 3, I can let x1, y1 be minus 1, 4, and x2, y2 is 3, 3. If I pop those bits in, I'll have the two x coordinates, so say minus 1 and 3. So minus 1 plus 3 gives me 2. And that's divided by 2, and that will eventually give me 1. And if I do the same with the y coordinates, we've got 4 plus 3 is 7. 7 over 2. You can leave as a fraction 7 over 2, or think of it as 3.5 if you so wish. Once we've discovered, we can look at a question where we're going to pull it all together, and we should be able to do all these little bits like a. So with this in mind, let's look to see if we can calculate the equation of a perpendicular bisector between 2 points. So we're going to use our y minus y1 equation again. That should come as no surprise. And the question will be as such. Calculate the equation of the perpendicular bisector of the points 4, 2 and minus 2, 8. So in this question, it's kind of important to point out that we're given none of the three things that we need. We haven't got our y1 or m or our x1, even though we've got points that are here. So with things to calculate, we've got 2 points that make up a line segment. It's only a bit of a line, because obviously if it was just a line, or I give the equation of a line, there is no defined halfway point, because lines can kind of go on forever. So the point on the line that we need, that it cuts through, is the midpoint, and we need to calculate this. And the gradient can be calculated just like before, like you do with the gradient formula. So I'm going to let 4, 2 be x1, y1, and minus 2, 8 be x2, y2. And if you use my midpoint formula, you'll see that the average of the 4 and the minus 2 is 1. So 4 minus 2 divided by 2 is 2 divided by 2 is 1. And the average of the 2 and the 8, if I add those together, 2 plus 8 is 10. And 10 divided by 2 is 5. And therefore our midpoint is just 1, 5. To calculate our gradient, we're going to do our y2 minus y1. Same thing as before. Our y2 minus y1 is 6. And minus 2 minus 4 is minus 6. 6 divided by minus 6 is minus 1. And therefore, we have a gradient, but we actually need the perpendicular gradient, remember, because it's a perpendicular bisector. So to do that, I'm going to take my existing gradient that I have, minus 1, multiply it by the gradient we're trying to find. We'll call it m. And that'll give us minus 1. If I divide across by minus 1, I will actually get that the gradient, or the perpendicular gradient, is actually plus 1, which is rather nice. So we have our gradient m to put in, and I also have the x1, y1 of a point that lies in a line, which in this case is the midpoint. So I'm going to take those values and I'm going to plug them in to my equation. So you can see that my y1 is 5, my x1 is 1, and my gradient is 1, and I'm going to multiply it with brackets, and 1 times x is x, and 1 times minus 1 is minus 1. And the only thing I've left to do is move the minus 5 to the other side. When you move a term to the other side, it becomes the opposite sign. So minus 5 becomes a plus 5. And then we have y is equal to x plus 4. And that is the equation of the perpendicular bisector, or the line that cuts that line segment between 4, 2 and minus 2, 8, right in half. So it's y equals x plus 4. And that should be that objective complete as well. So next time, in the next video that comes up in the series, we'll move on to a new topic. And we're going to do an introduction to calculus and differentiation, and it kind of links on quite nicely, because we've looked at how we find gradients and equations of lines for things that have straight line relationships that are already existing straight lines. And calculus and differentiation, you still calculate gradients and midpoints and all that kind of stuff, except you're doing it for curves and in real life motions, so to speak. So it links on quite nicely, because you'll see we're doing an awful lot of the things that we were doing beforehand. Our objectives of our lesson were to calculate the equation of one line that was parallel to another one, calculate the equation of a line perpendicular to another one, and calculate the equation of a perpendicular bisector of a line segment. And hopefully you'll see that there is an example for each right there. Remember, practice, practice, practice. For exercise solution quizzes and downloads around the subject, go to FlipMath and search for coordinate geometry. Feedback on all resources should be sent to @FlipMath. And I'll catch you next time. Thanks for watching. Bye.